Assalamualaikum and hi to everyone. Okay, today we are going to continue our lecture, which is the topic of probability distribution. Okay, so there is two types of probability distribution as you go on to read the notes that I've already uploaded at IUCAM Folio. Okay, which is discrete and continuous probability distribution. Okay, so in this video, we are going to explain on the examples that are given in the lecture notes. Okay, so we are going to start with the first one, which is on probability distribution for discrete random variable. So let's move to page 8 of the lecture notes. Okay. In this slide, okay, it is explained about the method for us to measure the probability distribution of discrete random variable. So the method used is we need to list all the numerical outcomes for the variable and the probability of succession matched with each result. Okay, so this is the steps that are needed for us to calculate the distributions of discrete random variable. Okay. So let's move to the first example, a very simple example for probability of discrete random variables. Okay, we just recap again. What is a discrete random variable? This is something that is countable, okay, that we can count. Okay, so we take a simple example, which is experiment of tossing a coins. Okay, so this experiment involved to toss two coins. Okay, two coins involved here, and how many times we toss the coins? For 4 times. So there are 4 events of us tossing 2 coins. Okay, so there must be 4 possible outcomes because we tossed the 2 coins for about 4 times. Okay, so we know that a coin. Okay, what is the possible outcome of it? Okay, because coins we have 2 surface, so the first one will be tail and the other one should be the head. Okay, so we have these two possibility of the outcome of these coins. Okay, and now we toss it for 4 times. Okay, so the first times of tossing these 2 coins, okay, remember that we are tossing 2 coins here. So the first possible outcome, which is the first times that you toss these 2 coins, so it can be, we can just put up here, we can have 2 possible outcome from the first experiment, which is both of it will become tail and tail. Okay, so this is the first one. Okay, so the first possible outcome. Okay, and then because we have 4 here, so another 2. Okay, it can be the first one, when you toss the coin you get tail, and maybe the second time, okay, because you toss 2 coins here, sorry, not second time, the second coins, for the second time you'll be getting head. Okay, and it can be also that the first time or the first coins you'll be getting head, and the second one you'll be getting tail. And for the 4th time we repeat again because 4 times here, so the 4th times maybe that you get both of it, head and head. So this is what we call the assumed desired outcome. Okay, because the assumed one is x equals to head number. So now of all of the listed possible outcome that you get from tossing 4 times the coins, okay, what is the probability of you getting the desired outcome, which is they want it to be the head number? Okay, so after we list out all the possible outcome, we need to make a table, okay, which involve the probability distributions. Okay, we have the value of x. What is the value of x? Okay, so because here we assume the desired outcome is x equals to head number. Okay, so it can be the value of the head number is 0. Why do I say this? Because you can see of all the listed possible outcome here, okay, you can see that there can be a possible outcome which have no head at all. So we can look at the first example here. Both of it are tails, so no head are found here. So there is the possible value of x, which is 0. Okay, and we go on to the second one. What is the possibility of the numbers of the head that we can get from the experiment? Okay, we can also get one head here, so 1. We can get another one, 1 also, and then another one, 2. So the value of x here, we get 3, 0, 1, and 2. So how do we count the probability of this distribution? Okay, so how do we count this probability here? Okay, so for the value of x equals to 0, which means that the value of the head number here becomes 0, is no head is found, right? So how many of this possible outcome? Okay, we look at the first list here, which is 1. Okay, and then do we have others that have 0 count of head? I think we only found at this first trial. Okay, because the other 3, we have at least one number of the head found in each possible outcome. Okay, so for the outcome of value of x becomes 0 here, we have only 1 from 4. Probability, right? Probability. Still remember what is probability? Okay, it is count from 0 to 1. So the probability of you getting 0 number of head, okay, is 1 over 4 possible outcome here. So how much is here? 1.1 over 4 is 0.25. Okay, so let's move on to the next one. Okay, so the probability of you getting the value of x, remember, is equal to head number. So head number of x, head number is 1. Okay, meaning that the possible outcome that you are getting the value of x equals to 1. Okay, let's look again at the 4 possible outcome here. The first one, we have 2 tails, which means we have 0 head. Okay, so move to the second one. Second one, we have 1 tail, 1 head. So here we got at least 1 outcome of head. So 1 here. Okay, so move on to the third one, because we want to see all of the listed possible outcome first. Okay, we want to sum up everything. Okay, so the third one. So on the first trial, or the first coins, you get head already, but the second one you get tail, which means that for this one also you get one number of head here. Okay, so we move to the fourth outcome. Okay, we look here, we got head and head, so which means that here is out already, because we get 2 heads number here. So how many possible outcomes that we get only one head number, which is here, and on the second one, and on the third one. So which means that you get 2 out of 4 possible outcome, which is equals to 0.50. Okay, so the same goes to the the 2, which means that x equals to 2 head number here. So which of the possible outcomes that you get only 2? You get 2 only. It is only 1 outcome, which is 1 out of 4 you'll be getting, or probability of you be getting 2 head number, which is equals to 0.25. So this is the example for us to list out the probability of discrete random variables, and using this simple example of tossing 2 coins. Okay. Okay, now let's move to the calculation of the mean for these discrete random variables. Okay, mean, which we can also call as expected value for discrete random variables. So this is the formula used to calculate for the mean, which is mu. Okay, mu is equals to mean, right? Equals to E. E is for what? E is for expectation. In the bracket x equals to the formula of calculating mean, which is, what is this? This is the sum of xi times with, this is probability of the preferred or the desired outcome of that experiment. Okay, So we look at again the example, the same example that we used just now, which is tossing two coins. Okay, and again the desired outcome is x equals to number of heads. Okay, so how to calculate the mean here? Summation of x times with the probability of x, which is the number of heads here. Okay, so we look again at the previous slide. Okay, if you look again here, we have already list out and make out a table of the probability distribution. Okay, which is the okay, we can write here. So this is the table. So for the event of you getting 0 head number is only 1 over 4, right? So 0.25. And again, the probability of you getting maybe 1 only, the number of heads is 2 times. So you'll be getting 0.050. This is the same like we calculated just now. And in the event of you getting 2, number of heads is 1 over 4. So 0.25 here. So you see that you have listed all the x's here and also the probability of your x on your right side. Okay, so how do we use this formula to calculate for the mean? Okay, so you just put in here. Okay. Zero. Okay, so we put in here 0, okay, because we need to see how many x here, right? 0, we times out with the probability of that you getting x0, which is 0.25. Okay, so we put here. Okay, maybe I use here. Okay, okay, 0 times with 0.25. Okay, plus with another one is 1 times with 0.50 plus with 2 times with 0.25. So the expectation or the expected amount is 1 here. Okay, this is what you get from this event of tossing two coins, okay, 4 times. Okay, this is how a simple example of you calculating the mean. Okay, so we move to the next measurement, which is to calculate for the variance and standard deviation. We have already defined this in previous lectures, what is on variance, what is standard deviation. It is always related to each other because in order for us to calculate for standard deviation, we just square root of your variance. Okay, so that's why we can get the other one, either one of the value, okay, because it's related to each other. Okay, so we want to look at the formula on how to calculate the variance here. Always remember the symbol for variance is sigma squared. Okay, and the formula for us to calculate the variance is using E expectation in the bracket x minus with mu. Always remember mu is the mean. Okay, and squared. Alright. So how we elaborate or we expand this formula? So you'll be getting the summation of x minus mu squared times with the probability of x here. Okay, so we look at the example of calculating this. Okay. So using the same example, tossing two coins, okay, and x equal to the number of heads that you'll be getting from each of the outcome. Okay, so calculate standard deviation, and we recall that your expectation or your mean that you have calculated just now is equals to 1. All right. Okay, so we look again how we want to calculate this. Okay, so for here, this is standard deviation. Okay, because you square root of your variance here, and how we plug in the value. Okay, still remember that the possible number of heads that you have already listed just now is 0, 1, and 2, right? Okay, so we just plug in x equals to The first one we start what? We start with 0. So 0 minus with 1 here. Why do we put 1? Because this is minus with mu. Mu equals to 1, right? So 0 minus 1. Alright. Okay, and then we squared times with what here? P. P of x. Okay, P of x. Remember that for this possible number of x, you'll be getting 0. You get your x, your px equals to 0.25, right? So we write here 0.25. Okay, so because this is a summation of all of this equation, so we plus, because we have another two possible number of heads here, 1 and 2. So 1 minus, this is 1 for the second one, right? Minus with your mu, which is 1. Okay, and again, the probability of x of getting 1 here is 0.5. Okay, you can refer to the previous slide. Okay, and the next one, we need to calculate for this one also. When the number of heads is this 2, so 2 minus with your mu, 2 minus 1, and this is your px for on the event of you getting number of head or x equals to 2, which is p2 here equals to 0.25, because you get 2 head, right? Sorry, 1 head of our 2 number of heads in one outcome. So 1 over 4, you get 0.25. Okay, so you calculate for this one and you should be getting this answer. Okay, we move to the next example. Okay, so if we assume that the returns of 1,000 ringgit are invested for two types of investment here. So we have fund X and also fund Y in three economic situations. So you have the first downturn, stable and increasing. And this is for each of the event, we have given the probability of each event here, which is event 1 downturn, stable and increasing. So we have all the probability and we have all the numbers or expected outcome or returns for each of the category here. Okay, so how we calculate for this one? So EX, which is your expectation. Okay, so you know that the first one, we have the X is equals to negative 25 here. And the probability of this is 0.2. Okay, and for the, we need to calculate for fund X and fund Y because we have two types here. So first we calculate for fund X. So negative 25 times with 0.2. This is your X. Alright, this is your PX. Right, so for the first one, X1, negative 25 times with 0.2. So we need to plus with, this is the X2. Okay, X2, which is positive 50 times with 0.5, which is for the probability of this event. Alright, and we need to plus with 100, which is X3, times with 0.3 here. Okay, so actually you need to, this is equals to negative 25, okay, times with 0.2, okay, and then 50 times with 0.5 and 100 times with 0.3. So you should be getting 50. Okay, so for the fund Y, the same process. Okay, so you take this is for X1, right? Sorry, this is for Y1. Okay, to indicate that this is fund 1, fund Y, Y2, this is Y3. So the same procedure here. So you just, this is will be equals to negative 200 times with 0.2 plus with 60 times with 0.5 plus with 350, okay, times with 0.3. So this one you should be getting 95. Okay, so the average returns, okay, of fund X and Y for each 1,000 invested are 50 ringgit and 95. Okay, so clear on this? for us to calculate the mean for this example. We continue again. Investment return again for the same example for fund X and fund Y. So now we want to look at how to calculate for the standard deviation. Okay, as I've explained, standard deviations is the square root of your variance. Okay, so what do we put here? We put your X because this is for fund X, right? So negative 25. This is the first X for fund X. Minus with your, what is here? This is your expectation or your mean for this fund X. Just now you already get 50, right? So negative 25 minus 50 squared. Okay, and then you need to plus. Okay, miss out here. Plus with the second one, which is sorry, not plus here. Okay, negative 25 minus 50. 50 is your expectation squared times with the probability here. Sorry, 0.2. Okay, so this is for the first one. Okay, and then the second one, 50, because this is the outcome for your fund X, the second one, X2, minus with your expectation here. So you times with the probability of you getting this second outcome, which is 0.5. And same goes to the third one, which is the X3 is 100, right? We minus with 50, which is your expectation squared, and times with the probability. Okay, so you should be getting, and I hope that you are also trying as we go along with this explanation, you should be getting 43.30. Okay, and I hope that you can repeat the same procedure for the second, which is this is for standard deviation of your fund Y. Okay, this, remember, it is just the same procedure here. It's just that you plug in the appropriate value, okay, for that fund. Okay, so again, this is your Y1 minus with your expectation of your fund Y. And this is the probability of this first event. Okay, and same goes on to the second and the third one. And you should be getting this, okay, for the fund Y. Okay, so although the return on the fund Y is high, it has a higher standard deviation, which means more variability, and the probability of loss is also high. Okay. Okay, we continue to the next subtopic with the changing to standardized normal distribution. Okay, so standardized z-score indicates how far above or below the individual data value is compared to the population mean in standard deviation units. Okay, and that's why when you look at the formula to change from X to normalize, okay, you see here this is the Z normalized, I mean standardized normal symbol equals to X minus with your mean, okay, divided by, what is this? This is your standard deviation. So it is as per explained in this definition here. And Z distribution always has mean 0 and standard deviation is equals to 1. Okay, so this is applicable for standardized normal distribution. Okay, so what example that I want to show here for you is on how you want to convert to the standardized normal distribution. So we look at this example. If X is normally distributed with mean 100, okay, so you know that this is the mean, which is the mu, and standard deviation of, so standard deviation, you know that this is the symbol of 50 ringgit. Then the Z value of X equals to 200 is, so how do you calculate this? So again, the formula is Z equals to X minus with mu divided by standard deviation equals to 200 minus with mu. What is the mu? 100 divided by your standard deviation, which is 50. So how much do you get, class? Can you please try? 200 minus 100 divided by 50. All the information is given here. So I guess you already get the answer, right? So it is 2.0. So this shows that x equals to 200 is 2 standard deviation or 2 increases for 50 units above 100 ringgit mean. This is mean that is given in your question. Okay, so we continue with the cumulative standardized normal distribution table. Okay, I will show you the table for you to refer when you want to calculate for this type of question. So the cumulative standardized normal table indicates a probability less than the desired value of z. Okay, so for example, if you look at this slide, okay, P, probability of z. So you always, when you saw z is standardized normal distribution, okay, less than 2.00. So if you look at from this bell shape, because we're talking about normal distribution, right? And always remember that normal distribution is always in a bell shape. All right, so z, if it's less than 2.100, 2.00, okay, so if you look at the table, okay, of that cumulative standardized normal table, okay, it is 2, right? So you should be getting 0.9772. Remember that the cumulative standardized normal distribution table, it shows the value lesser, right? Less than the desired value of z. Okay, so if you're for the example just now, z less than 2.00, which means that you can straight away read from this table 2.0, you get 0.9772. Okay. So we start with a first example that I want to show you and explain to you. Okay, so use the cumulative standard normal table to find, okay, between probability of 0 and 1.32. So what is the probability of z equals to 0 here? Okay, z equals to 0 here. So you know that, okay, from this table, so the first one, from the table you get 0.5. Okay, so you write here 0.5. And then from the table also, you read 1.32. Okay, how do you want to read? This is 1. Okay, this is 1.3. Okay, 1.32. 0, 1, and 2. 0.9066. Okay, 0.9066. Alright, so probability of z in between 0 and 1.32 is actually 0.9066 minus 0.5. Okay, it is between here, right? 0 and 1.32. So in order for you to get the value is, what is this? It is more than 0, but it is less than 1.32. So it should be between here, right? So your answer is 0.4066. So this is how you calculate. We look at the second example. Calculate P in between negative 1.10 and 1.32. Okay, so if you look here, we have two areas that they have showed here or shaded here. So area 1, z equals to negative 1. Area 1 here, we get z equals to negative 1.1. Not get, but actually this to show you first. This is the area 1, z equals to negative 1.10. Okay, and we have the other one, which is area 2, 1.32. So the given question is that calculate for the probability of the area, okay, which is more than negative 1.1 and lesser than 1.32. So we know that more than negative 1.10 should be in this area, right? Moving here. All right, and z less than 1.32. So it should be less than. So it is in this area. All right. So how do we calculate this? probability of Z equals to negative 1.32 minus probability of Z negative 1.10. Okay, so we know just now we already read from the table Z negative 1.32 less than this value is 0.9066. So how about this value of Z equals to negative 1.10? Okay, so if you look from this table, 1.10 is actually 0.8643. Okay, 0.8643. So it is what is the description of you reading this table? Remember that the value given here is for lesser than the desired amount. But for this question, the amount that's given to you is actually P, or probability of Z, okay, is more than 1.1. Okay, so this is less than 1.1. So 1 minus with 0.8643. You should be calculating for that. You should calculate for that. Then only you can get your answer. Okay. Okay, here. So, sorry. This is probability Z equals to negative 1.1, right? But in this question, it is more than. So your answer just now is 0.8643, right? So you should minus this one in order for you to get P Z less than negative 1.1. So this one you should be getting 0.1357. Then only you can minus here. Okay, so I hope that you are so calculating as we go along with this example. So you should be getting 0.7709. Okay, so that is why it is important for you to graph it, okay, for you to have a clear view, okay, on what are you calculating, and be careful, okay. So the point is for you to shade this area is for you to get a rough idea of what to minus, which part to minus which part, okay, and then only you can calculate for each of that probability, okay. And that is why important for you to do this first step, and then for you to write here on what you want to calculate, and then only you look from the table the value, and the next one you should be getting your answer. Okay. Okay, this one example of you to calculate also again for standardized normal distribution. Okay, so given the question, usually the average time to complete each statistical question is 12.1 minutes. So you see here, this is average, which is your mu. Okay, mean. Assuming normal scattered time variables with a standard deviation of 2 minutes. So standard deviation, again, I repeat to you, standard deviations means that it is the square root of your variance, okay? What is the probability that time required by Ahmad to solve each question? Okay, so you will look at the first example here. If it is greater than 14.1 minutes, greater than 14.1 minutes here. Okay, so first of all, of course, we need to put in all the information given for us, okay, so that we can have a rough idea to start off with what and to plug in into the formula. So this is the mu, 12.1 minute, and we have this. What is this? This is standard deviation. The symbol is always sigma, okay, or x. This is normal distributed, right? So N is for normal, this is for your mu, this is for your standard deviation. Sorry, this is for your variance. Okay, so this one is for mu, this is for variance. Okay, now they want you to calculate for time is larger than 14.1, larger. So again, we have z equals to x minus mu divided by your standard deviation equals to, what is your x? Given here is 14.1 minus 12.1 divided by your standard deviation, which is 2. Okay, so you should be getting 1 here. Alright, so it is larger than 1. So this is what you'll be getting of a time is larger than 14.1. Okay, so the next question is time less than 8.1 minute. Okay, time less than 8.1 minute. Okay, so this is your x given to you. This is your x, okay? Z equals to x minus mu divided by your standard deviation, which is given your x is 8 minus 1, 8.1 minus 12.1 divided by 2. So you should be getting negative 2.00 here. Okay, so that is why this is for you to calculate for z. That's why it is indicated or denoted here that z equals to negative 2.00. Less than 8.1 minute is z equals to negative 2.00. Okay, so for the C1, time is between 10.1 and 14.1. So now you want to know in between what z value. Okay, so we put as z lower. Okay, z lower is a smaller value lah. Okay, so we take x minus mu divided by standard deviation. It will be the lower one, 10.1 minus with your 12.1 divided by 2. So you should be getting negative 0.11 here. Alright, so that's why the lower is negative 11. Negative 1.00. So z upper equals to x minus mu divided by variance equals to 14.1 minus 12.1 divided by 2. It is equals to 1.00. So you look here in between negative 1 and positive 1 for the value of x, 10.1 and 14.1 minutes. Okay, for the last question here. Okay, the same one in between 10.1 and 16.1 minutes. So you can try to start off and calculate. So same like just now, z lower equals to what class? We need to start with what? X, right? X minus mu divided by standard deviation. So what do you put here? 10.1 minus 12.1. Okay, divided by 2 equals to negative 1. Okay, so for the z upper, same procedure, x minus mu divided by standard deviation. You just plug in the value 16.1 divided by 12.1, minus 12.1, sorry. Okay, divided by 2.1, so you should be getting 2.00 here. Alright, so what does this mean? This is z, right, for your lower. So you should indicate it here as your area 1, which is the lower part. Okay, so z upper, why we put it here in this area less than 0? Because you get negative, right? So of course it is in the area of less than 0. Alright, so z upper, because it is a positive value, so it is on the right side. So it will become your z equals to 2.00. Okay, I think that's all for our sharing session for the explanation of all the examples in this lecture notes. Okay, I hope that it is well explained and you guys can try to calculate for each of the examples that I've explained and shown to you. Okay, and we meet again